Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article from Quanta magazine. Chatbot software begins to face fundamental limitations. It's all about the surprising limitations of large language models, even the most advanced ones like GPT-4 and Gemini. Intriguing, right?
Absolutely. I've been following this field closely, and the findings are quite unexpected. So what are these limitations specifically? Are we talking about simple errors or something more fundamental?
It's more fundamental than simple errors. The article highlights research showing that these models, despite their impressive capabilities, struggle with compositional reasoning. Think of Einstein's puzzle. Those logic problems with multiple interconnected clues. LLMs often fail to solve these, even relatively simple ones.
I see. So it's not just about the sheer volume of data they've been trained on, it's about their inherent architecture?
Exactly. Two research teams independently found evidence suggesting that the transformer architecture itself, which underpins most LLMs, has mathematical bounds on its ability to handle complex, multi-step reasoning. One team, led by Nohad Ziri, tested LLMs on tasks like Einstein's puzzle and basic arithmetic, finding significant limitations in their accuracy as the complexity increased. The success rate plummeted.
And the other team? What was their approach?
Binghui Peng's team took a more theoretical approach. Using computational complexity theory, they proved a mathematical limit for single-layer transformers, and then extended that to show limitations even in multi-layer models. It's not just about the size of the model. There are inherent limitations in how they process information.
So it's like hitting a wall, regardless of how much bigger you make the model? That's a pretty significant finding. Wow.
Precisely. They found that even scaling up the model doesn't necessarily solve the problem if you also scale up the complexity of the task. It's a fundamental architectural constraint. But, it's not all doom and gloom.
Oh, are there workarounds?
Yes. Researchers are exploring ways to improve things. One approach involves adding extra information to the input, like embedding positional information for numbers to improve arithmetic accuracy. Another is chain-of-thought prompting, where you provide a step-by-step solution within the prompt itself. This helps the LLM break down complex problems into smaller, manageable ones.
So it's like giving them training wheels, in a way? Interesting. But these are still workarounds, not a fundamental solution to the architectural limitations, right?
Correct. These techniques extend the capabilities of LLMs, but they don't eliminate the underlying mathematical limits. The article emphasizes that you can always find a compositional task complex enough to exceed the capabilities of any given system. Even with these improvements, it's a fascinating challenge.
It really is. It makes you wonder what the next generation of AI architectures might look like. Perhaps something fundamentally different from transformers?
Absolutely. The article suggests that this research is a call to action for the ACI community to explore alternative architectures. The current limitations are a significant hurdle, but they also present an opportunity for innovation. It's a very exciting time for ACI research.
Indeed. Thanks for breaking this down for us. It's a complex topic, but you've made it clear and engaging.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time with more insights from the world of technology. Goodbye.
Bye-bye.